Hello, welcome to this video about morphology and how to recognize and make use of morphological tags. Morph means shape in Latin, hence as the name suggests, morphology is the study of word shapes or better study of word forms. Morphology analyzes the structure of words and part of words such as stems, root words, prefixes, and suffixes. So morphology describes how to form new words from existing vocab words and how some vocab words are related through their shape and meaning. In this video, we will go through a bit of concepts. What are the types of suffixes? What is a lemma? What are morphological tags? And then we dig practical concepts a bit. Important practical concepts are what is a stem, what is a lemma, how to use a stemmer, how to use a lemmatizer, different types of stemmers, when it makes sense to use a stemmer versus a lemmatizer. English morphology is rather flat, so we will be seeing some example word forms from German, Spanish, and even Turkish. As we said before, morphology analyzes how to produce new words from other vocab words. Think of an English noun, and you can make another word by adding a plural suffix, hence. Now think of a verb run. You can generate two new words, ran and running, by applying a verb inflection, which is a tense. Another example is generating comparative and superlative forms of adjectives such as big to bigger and biggest. Now we do a bit different thing here. We will change the meaning a bit. Look at these words. Weak becomes weaken by attaching the suffix an. Here word post change, an adjective became a verb. In the second example, we make an adjective into a noun. Slow becomes slowness. Do we have to attach a suffix? Not really. We can attach a prefix too. See the examples here. With prefixes highlighted: amoral, illegal, irresponsible, hyperspace, exile, and so on. After seeing the examples, we can go more formal. As you see, there are some base forms in language's vocabulary. Then you attach some prefixes and suffixes to form new words. Hence, a lemma is a base form. An affix is a morpheme that is attached to a base form or a lemma to form a new word. An affix can be a suffix, prefix, or interfix, and a bit more types. Suffixes attached to the end of the word, prefixes attached to the beginning of the word, and infix comes in between. Please see the last example from German. Again, concepts here. Lemma, which is a base form. An affix is a morpheme that attaches, which can be a suffix, prefix, or infix. Perfect. Now, affixes can be divided into two: an inflectional affix or a derivational affix. As we see before, some affixes produces grammatical variants of the same word that don't change the post tag and the meaning. Examples again. The first block. This is called an inflection. Here we inflected these words. Contrast is called a derivational suffix. This block, you change the meaning of the word and possibly the post tag. Examples again. Please compare. English has rather a flat morphology, but in morphologically rich languages, there are quite a lot of derivation and inflection is going on. Here are some examples from German, examples of articles inflected to case and gender, then a verb inflection example, and then some derivation examples. Now, how do we represent the morphological analysis of a word? Answer is morphological tags. Again, one can find the tags in universal dependency resources as always. Let's see with an example. We start with English. We will see UD datasets in detail in the next video. Hence, in this video, I will just show the tags, not the datasets. Okay, we see three examples. First example is a noun, president. We see the morphological tag, number is singular, and Lemma is president. Second word is a verb, nominated. It is a third person past tense verb, and word lemma is nominated. Last word is an adjective, best. Lemma is good, and it's a superlative adjective as we see from the tag. We also see the post tags in two forms, universal tag and panty-rebank tag. Okay, now comes the fun, some German examples. This is an article with a very long morphological tag sequence. Okay, this article is in genitive case. It's a definite article, gender is masculine, and number is singular, and it's a third person. Next is a noun, Übergang, is accusative, gender is masculine, this is a plural noun, and this is the lemma. Final example is a past tense verb. Please notice that both morphological and enhanced post tags are different because German and English are different languages. So, we saw some concepts already. Now we can move on to more practical concerns. We will see details of lemmatizers and stemmers. Before that, what is a word stem? A stem is a part of the word that carries minimal meaning. Immediate example, universal and universe. Though universe is not a legal word of English vocabulary, still it carries a meaning and it revokes some semantics of the word universal. So some facts about stems that they don't have to be vocab words. They are found either by cutting some prefixes and suffixes, hence always a substring of the original word, and they should carry the meaning in a minimal way. Biggest difference between a lemma is that lemma should always be a vocab word, always. And lemma doesn't have to be a substring of the original word if the word form is formed by some irregular inflection process, just like in this example. Stemmers are indeed small and efficient algorithms that chops a string from the start and end. Most algorithms has some rules, like this, and has a list of common prefixes and suffixes, like this. Here is a part of the English snowball stemmer algorithm that I took from the NLTK page. We see the suffixes that will be processed by the algorithm. Let's shoot some examples. I will import snowball stemmer from an LTK stem module here, create a stemmer object, and stem those two words, universal and university. Both university and universal has the same stem, universe. Don't be surprised, stemmers can have interesting results. So, stemmers are choppers. Hence, one can chop the string in different ways. As a result, same language can have more than one stemmer algorithm. We already saw the snowball stemmer of English. There is one more popular stemming algorithm called Porter. Indeed, snowball stemmer is a newer version of Porter's stemmer. Snowball is sometimes called Porter 2. Porter's stemmer is an old and gentle stemming algorithm. Snowball stemmers is just a bit more aggressive, cuts a bit more of the input strings. There is one more, a totally different algorithm called Lancaster Algorithm, which is quite aggressive and sometimes cuts quite long substrings. You can find this algorithm in NLTK package 2. Let's shoot some examples. In these two examples, result of Lancaster is shorter. Indeed, oath is cut a bit too much, in my opinion. Here they are. Okay, so Lancaster is sometimes too aggressive and can lead to not so optimal results, but for big corpora, sometimes it really compactifies the corpus and can improve the statistical quality. That's a bit surprising because intermediate result after stemming is not so great, but overall result is very, very good. It can happen. So always try different ways in NLP in general. You never know what works better. How about lemmatizers? Lemmatizer algorithms are much more sophisticated and complicated because lemmatizers need to know the language's grammar and word formation rules. As an example, Space now has a new component called edit-tree lemmatizer, which is a statistical algorithm that you feed the post text and other attributes so the algorithm is context-aware. Perfect. Now we see both ways of obtaining a semantic minimal unit, a lemma, or a stem. Finally, we see what makes sense to use versus a stemmer or a lemmatizer. For some languages, stemmer is okay, such as English or Spanish. But for languages, a stemmer just cannot deal with the morphology, such as German or Turkish. As a rule of thumb, always pick the algorithm that makes your corpus more compact without losing semantics. We reached the end of this video. Hope you enjoyed. In the next video, we will finally see the great universal dependencies in detail. Until next time, bye bye. See you at the next video.